Greetings all. This is a JH Productions. I tell you that it's a JH Production so that you won't try to copyright it and that you won't try to sell it on eBay for more than $1 million. It's a JH Production for section 4-2. So let me get that written down there. I will give the class a note card. I will give you a note card here in the very near future so that you can write down the product rule and the quotient rule. You'll want to pause the video today and get that written down so that you have access to it. And then once we get rolling, I'll make sure you have a note card to make sure everything goes well. But what I will do today is I'll answer whatever questions you had over 4-1. Of course, you won't be here, so I won't be able to do that. There is a skill check on here, and I put the answers on there. So do the skill check and then compare it to my answers. Make sure that you understand it. And then I will cover 2 rules today. Kind of expands on the power rule. And then the assignment on 4-2 will be out of the book today. And then we won't be quizzing next time. So I knew that part would break your heart. So there's page 1 of the skill check. You can always pause the video and try the skill check. Make sure you use correct notation. But there's the first 4 problems. There's the next 3 problems. And then I did put the answers on here for you so that you can compare them and make sure that you're right. So here goes the meat of the lesson today. What I need to do with you today is show you how we find the derivative when 2 functions are multiplied together. So take a peek at this one first. What I'm going to do first is the easy way to do it. The easiest way to find the derivative is simplify first. So if I really wanted to find this derivative, I would simplify this and call this 8x to the 6th plus 24x to the 4th. And then when I find the derivative, like we did last time using the power rule, this becomes 48x to the 5th plus 96x cubed. When you can simplify, guys, that's the easiest way to find the video. Here's why I'm not going to let you simplify much today. Next time, I'm going to introduce to you the chain rule, and what I'm going to do to you is I'm going to put powers like a 3, a 4, a 5 up here. Then you can't simplify it first. So that's the reason I got to teach you what's called the product rule. The product rule says this: the derivative, d dx, the derivative of 2 functions multiplied together can be found by doing this. Let one function be f of x, let the other function be g of x. The derivative then is the derivative of the first function times the second function plus the first function times the derivative of the second function. In college, I didn't want to write out all that. Perhaps I was lazy, who knows. So I just memorized f prime g plus fg prime. And that told me the derivative of the first times the second plus the first times the derivative of the second. Here's this same problem using the product rule. Like I said, it's longer, but got to see the big picture on where I got to get you to. So here's what the product rule would look like using this. This would become my function of f of x. This becomes g of x. I say f of x and g of x, and then really once I get rolling, I say the derivative of the first times the second. So here's what it would look like. F prime of x is going to be the derivative of f of x, which is 12x squared, times the second, which is 2x cubed plus 6x, plus the first, which is 4x cubed, times the derivative of the second. Well, the derivative of 2x cubed plus 6x is 6x squared plus 6. Hey, the calculus part is all done. Now I'm just going to simplify this. So when I go and simplify this, I get 24x to the 5th plus 72x cubed plus 24x to the 5th plus 24x cubed. And then when I simplify my like terms, I get, it looks like 48x to the 5th plus 96x cubed. The same answer I got up there. I kind of did this for 2 reasons. Showing you that when you can simplify, that's your best bet. When you can't simplify, there's a lot more work involved, but this is the steps of our product rule. So if you need to, guys, pause the video, but write down this rule somewhere so that you have it. I'll use it for the next 3 or 4 examples, and then we'll move on. So here comes my next example. I would like to find this derivative by the use of the product rule. So I'm going to have f prime of x equal, hey, don't get caught up that I'm calling this f of x and this g of x. It's just notation. Even though there's an f of x here, this is basically the first and the second. I could call them first and second, a's and b's, that doesn't matter. But the steps is this. I'm going to have the derivative of this, the derivative of the first, I'm going to have 6x times the second, which is x squared plus 2, plus the first, 3x squared plus 4, times the derivative of f of x, or times the derivative of the second. Well, the derivative of x squared plus 2 is 2x. The calculus part is all done. After that, it's going to be the algebra. So let me distribute. And on the video here, guys, just so it's not boring to you, I usually click right along with my algebra. So 6x cubed plus 12x plus, let me distribute that 2x, 6x cubed plus 8x. It looks like my ending answer for my derivative is 12x cubed plus 20x. Hey, notice the notation, the f prime of x. There's my answer. So there's my second example using the product rule. I've got more coming, of course. So this would be the next example on your worksheet. I'm going to throw in some radicals. I got to make it pretty tough for you today. Hey, but what I'm going to do first is I'm going to rewrite f of x. So notice I called it f of x. I'm going to rewrite this so that I could use the power rule that we learned last class. So instead of seeing the square root of x, I'm going to see x to the 1/2 plus 3 times x squared minus 5x. Now when I do this, this is my function of f, or my first. This is my function of g, or my second. So when I start doing this, f prime of x is going to be, I've got the derivative of the first. Well, the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Normally, I would go ahead and move that negative 1/2 to the denominator, but I know I'm going to have to simplify, so I'm going to leave it up for now. So I've got the derivative of the first times the second, plus the first, which is x to the 1/2 plus 3, times the derivative of the second. But the derivative of the second is 2x minus 5. Okay? You'll hear me say this a few times today. The calculus step is done now. Rest of it is algebra. So f prime of x is going to become, I'm now going to distribute this 1/2 x to the negative 1/2 through. So I'm going to get 1/2 x to the negative 1/2 plus 2, which is 3/2, minus 5/2 x to the 1/2. I got that 1/2 by going negative 1/2 plus 1. Now when I come over here, I got to FOIL that thing out. So here goes the FOIL. When I go here to here, I'm going to get 2x to the 3/2. When I go here to here, I'm going to get minus 5x to the 1/2. Here to there is plus 6x minus 15. Algebra step. Hey, go through and find any like terms that you can. So f prime of x is going to be, there's a 1/2 x to the 3/2 and a 2x to the 3/2, which is a 5/2 x to the 3/2. Oh, here's a x to the 1/2 and here's an x to the 1/2. Negative 5/2 minus 5 more is negative 15/2 x to the 1/2. And then I got a plus 6x minus 15. There's my derivative using the product rule. If I get going too fast on the video, guys, pause it, backtrack it, do whatever you need to do. I found, though, that if I'm too slow with my pauses, it kind of gets boring. So there's my second one using there's my next one using the product rule. Here's my next one. I'm going to find this using the product rule again. So what I need to do first is rewrite f of x. So notice I called it f of x. I didn't call it f prime of x or anything. So I'm going to think of this as 5x to the negative second times 3x cubed plus 6x. Normally, after today, I will give you the green light. The easiest way would be to simplify this and then find the derivatives. I'm asking you not to do that today to get you good with the product rule. So here goes the derivative of this using the product rule. I'll go the derivative of the first. So bring down that negative 2 times the 5. So I'm going to have negative 10, x to the subtract 1, and get negative third. So there's the derivative of the first times the second, which is 3x cubed plus 6x, plus the first, which is 5x to the negative second, times the derivative of the second, which is 9x squared plus 6. Okay. The calculus part's all done. Let me simplify this, and I'm not going to get rid of my negative exponents until the very end. So when I distribute here, I'm going to get negative 30 x to the 0, so I'm not even going to put that in there because that's 1, minus 60x to the negative third. I'm sorry, negative second. Negative 3 plus 1 is negative 2 today. So that takes care of that. Let me come over here. That becomes 45x to the 0 plus 30x to the negative second. When I do some more algebra and simplify this, I've got negative 30 and 15, or negative 30 and 45 must be getting late. Negative 30 and 45 make 15. Negative 60 and 30 make negative 30x to the negative second. So here's what my derivative would look like. I got 15 minus 30 over x squared. Hey, notice that the only thing that got the x squared was the 30, not the 15. If I were to get a common denominator, then I could see 15x squared minus 30. So there's one form of the answer. There's the other form of the answer. Okay. So there's yet another example. Since this one's just like what we did, I'm going to skip this one for you and kind of move on to the next one. Ton of algebra there. But here's my next thing I need to talk to you about. This is called the quotient rule. The quotient rule appears whenever you're working with a divisor, a fraction. So a function over a function. So let me explain the quotient rule to you first. It says the derivative, d dx, that's notation for the derivative, of a function divided by another function can be found by doing this. It's the derivative of your first times the bottom. And instead of saying f and g, I'll say top and bottom. So the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. In college, I shortcutted that a little bit. I went f prime g minus fg prime. The derivative of the first times the second minus the first times the derivative of the second, so top and bottom, all over the bottom squared. Okay? Really, if I wrote a calculus book, guys, I would have went T and B. The derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. But I didn't write the book, so here goes. So here's what this looks like. In this example, this is my top, this is my f of x, this is my g of x. So when I go to find this derivative, it's going to look like this. The derivative of the top, or the derivative of f of x, which is 0, times x squared, minus the top, f of x, 12, times the derivative of the bottom, which is 2x, all over the bottom squared. So once again, guys, the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. When I simplify this now, I'm going to get negative 24x over x to the fourth. So my ending answer, negative 24 over x cubed. Okay. Hey, compare that to the shortcut way. What we would have done last time, we would have thought of this as 12x to the negative second, and then its derivative is going to be negative 24x to the negative third. That came down, subtract 1, and then we would have got rid of the negative exponent. So, same answer. You're stuck using the quotient rule, though, if you ever have more than a monomial in the bottom. So here's my next example, which is on your same slide. I just gave myself more room to work with it. So here's what the next one looks like. This is my function of f. This is my function of g. This one's got a ton of algebra in there. But here's what it's going to look like. When I go find the derivative, I'm going to have the derivative of f, or the derivative of the top, which is going to be 4x minus 4, times the bottom, which is going to be 2 minus 3x. So it looks like here in a minute I'm going to do some FOIL. Minus the top. Hey, notice I'm leaving a little space this time. I've got the top times the derivative of the bottom. Well, the derivative of the bottom is just negative 3. I just left a little space so I could put that up front. All over the bottom squared. Hey, and don't FOIL this out. That's more work for us. We don't want to FOIL that out. But we are stuck with the FOIL on the top. So, hey, back-to-back negatives become a positive. So here goes the algebra here. When I FOIL 4x minus 4 times 2 minus 3x, I'm going to get a 8x minus 12x squared minus 8 plus 12x. And let me distribute a 3 now. So I'm going to get plus 6x squared minus 12x plus 9 all over 2 minus 3x quantity squared. Simplify any like terms that you could find on the top. Here's a negative 12x squared and a positive 6x squared. So I got negative 6x squared. In terms of the x's, there's a 8x and a 12x, so I'm up to 20x minus 12x. So I've got plus 8x. And then negative 8 and 9 make a plus 1 all over 2 minus 3x squared. So there's my derivative. That's the quotient rule. In layman's terms again, the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. I've got some more coming your way, so don't panic. Okay. Here's your next example, 3x plus 7 all over 8 minus 2x. You are stuck using the quotient rule on this because this does not allow you to simplify. I can't simplify. I can't cancel these x's out or anything. So I am stuck with the quotient rule. That's the only rule I got. So it's going to look like this. F prime of x is going to look like the derivative of the top, which is 3, times the bottom, which is 8 minus 2x, minus the top. Notice I'm leaving a little space again because I peeked ahead and I saw that the derivative of the bottom was negative 2 all over the bottom squared. The calculus part's done, so let me start doing some algebra on this. I'm going to distribute, so I've got 24 minus 6x. Back-to-back negatives become a positive. Let me distribute, so I've got plus 6x plus 14 all over 8 minus 2x quantity squared. If I simplify this, it looks like I'm going to get 38 over 8 minus 2x squared. So there's my derivative. So notation-wise, I'm going to say f prime of x is 38 over 8 minus 2x squared. Okay? That's really my last quotient rule. I've got 3 or 4 here that we're as a class going to say, hey, what's your best way to find this derivative? Since you're just stuck with the video, I'm going to kind of tell you real quick the best way to find the derivative, and then I'll show you how to find it. So here's my first example. F of x is 3x to the 5/2 all over x. We could use the quotient rule on that, but that's not the best way. I could simplify this to be 3x to the subtract your exponents 3/2. Now I got a really simple power rule. That's what we learned last class. So f prime of x is going to be, bring that 3/2 down, I'm going to get 9/2, x to the subtract 1, 1/2. There's my answer. Okay? So if you can simplify first, simplify. On my next one, I can't simplify first. So I'm stuck using the quotient rule. I avoid the quotient rule when I can. This one I just can't. So it's going to be the derivative of the top times the bottom minus the top. Notice I'm leaving a little space. Times the derivative of the bottom, because the bottom is 3, all over 3x minus 5 squared. And like I said, guys, don't FOIL that out. You'll see why soon when I ask you for critical points. So dy dx is going to be, I'm going to have 30x squared minus 50x minus 15x squared minus 18 all over 3x minus 5 squared. When I bring this home then, combine my like terms, I spy a 15x squared minus 50x minus 18 all over 3x minus 5 squared. So there's my derivative on that one. I couldn't simplify first, so I'm stuck. Hey, I've got 2 more, so hang with me. Here's my f of x equal that. We could use the quotient rule on this if we wanted to. I don't want to, guys, because this simplifies. Whenever there's a monomial in the bottom, it'll simplify. So I'm going to take each of these terms over x squared. So 3x cubed over x squared is really 3x. 11x squared over x squared is 11. 6x over x squared is really 6x to the negative 1. So I got plus 6x to the negative 1 because I subtracted my exponents, plus not 4 over x squared, but 4x to the negative 2. Hey, notice I did this. I wrote each and every one of them so I could use the power rule on it. If you recognize that, watch how easy this derivative is in. Derivative of 3x is 3. The derivative of 11 is 0. The derivative of 6x to the negative 1 is negative 6 over x squared. The derivative of 4x to the negative 2nd is negative 8 over x cubed. Then I'm all done. Don't panic if you look in the back of the book and your answer is a little bit different. If I was to get a common denominator, this would be my answer. 3x cubed minus 6x minus 8 all over x cubed. These are the same answer. Okay? So don't panic on it. Hey, my last one. I got x to the 4th plus 3x squared times 1 over x squared. I could use the product rule on this, and that would get me to the answer. But I'm going to simplify first. And if I do that, if I distribute that 1 over x squared, I'm going to have x to the 4th over x squared, which is x squared. Then I'm going to have 3x squared times 1 over x squared, which is just 3. So if you saw that it simplified, check out this derivative. F prime of x is 2x. I'm done. If you would have did that bad boy using the product rule, it would go for a little bit. So, hey, there's what we got. So like I said, guys, pause the video, fast forward the video, mute the video if you don't like the way I sound or anything, but that's section 4.2. Like I said, I've got you in the book, in the, you got your lesson right there on your assignment. I've got you in the book, then I'll put you in Math Excel next time. So come in if you have any questions. Good luck.